Okay, I will start this video about the splines, but we will concentrate on the cubic type because it is very important. It's widely used in practice. So let's talk about splines, cubic, splines. Okay, basically, let's assume that we have let's assume that we have 3 points. Okay, now we want to join the first line. Let's say, let me draw it. This is one line, and then the other line is this one. Okay, so we call this let's name this S0 and this S1. So we have two curves, S0 and S1, and both are cubic. Okay, so S0 is equal S0, 0. Let's assume this is X0 and here Y0. Here is X1 and here we have X2 and here we have Y1, Y2 and here Y1. Okay, so the first curve is a constant plus another constant is 0, 1 times x minus x0 plus another constant is 0, 2 x minus x0 squared plus another constant is 0, 3 x minus x0 cube. So that's why we call it cube. We have 3 parameters. One is linear, is 0, 1, and one quadratic is 0, 2, and one cubic is 0, 3, plus a constant is 0, 0. Similarly, if we go to S1, we have a constant, S1, 0, okay, plus S1, 1, x minus x1 plus S1, 2, x minus x1 squared plus S1, 3, x minus x1 cubed. So it's 0, the first the function number 0, its start point is x0, okay, and S1 its start point is x1, okay. So this is the start point of the first of S0, and this is another start point. So this is start of S1, while this is start of S0. If we look at this one, here is end of S1, while this one is start of S1 and also end start of S1 but end of S0. So that's the middle one, is the end of S0, but it is the start of S1. Now, if you look carefully at these two lines, each segment S0 or S1 has 4 parameters we have to calculate. So the unknown of these parameters S0 0, 1, 2, 3, 4. And for segment, the second segment S1 is also 4. So total of what? 8 parameters we have to determine. How do we determine these 8 parameters? We need 8 equations, okay? Because each segment has 4 parameters. How we do that? Let's see. For the first segment here, okay, S naught is equal S0, 0 plus. So at the beginning of the node, at the start of the node, at x equals 0, x minus x naught is 0, and x minus x naught squared is 0, x minus x naught cube is 0. So what is left? Only S naught naught. So this should be S naught naught should equal to y naught, because this point here, okay, this point here, y naught should be the start of the first segment, S naught, okay? And similarly for the second segment, S1, S1, 0 equal y1. So here, start of SP lines, okay? So this will give you what? 2 equations, okay? So the first equations we obtain, that's the start of each segment. Start of each segment should equal to the value of y at that point, at the start point, okay? So we can use the endpoints to get another 2 equations, okay? So start of points we had, okay? If we choose x equal x1, then for okay, let's look at it. For first SP line segment S naught, we have S naught at, let's say, at x1, which is end of segment 0. So in this case, S naught is actually equal, S naught here at x1 is equal S0, 0, okay, plus S0, 1, x1, x minus x naught, minus naught, plus S0, 2, x minus x naught squared, plus S0, 3, x minus x naught cube. We look at this one, we evaluate this. This is the function of S naught. We evaluate it at x1, just to replace x, y, x1. Okay? Then what this should equal? This should equal y1. We look back here. So that's the segment here. The end of the segment, okay, should equal to y1. Okay? Now, similarly, if we apply it to for, let's say, for second SP line, okay, S1 at x2. So this is x2 is the end of spline 1, the second segment. Now we have S1 is equal to S10 plus S11 x, okay, minus x1 plus S12 x minus x1 squared plus S13 x minus x1 cube. Now this is S1 evaluated at the end. Here we have evaluated at the start, right? y naught and y1. Here we evaluate it at the end. So we say at x2 at the end, then we will replace x by x2, x2, and x2. And this should equal to y2. Okay? So we had, for the start of the splines, we had y naught, this is the start of the spline, y naught and y1. At the end of the spline, we have y1 and y2. So this is start, this is end of splines. Okay? So we had two equations for the start of the splines, and we have two equations for the end of the splines. So we have four equations. What is left? Another four equations. Now, okay? Now, for these other four equations, we obtain them from the first derivative and the second derivative. Now, if we look at these two segments here, it's not as S1. At x1, at the midpoint intersection between S0 and S1, we have a function of S0 and a function of S1, and they are equal. Okay, and they are equal. That's we use the endpoints. They are equal here. Okay. Now, if we take the first derivative of S0 and equate it with the first derivative of S1, evaluated at x0, y0, we get one equation. And if we take the second derivative of S0 and equate it with the second derivative of S1, evaluated at x1, we get a second equation. Let's see. Okay? At midpoints, at intersection points, we evaluate ds naught with dx, okay, and d. This is evaluated at x1, and we have ds1 dx evaluated also at x1. They should equal. So we want to make the first derivatives equal, okay? And the second derivative with dx, also evaluated at x1, should equal second derivative, okay? Second derivative of s1, okay, with dx, evaluated x1, they are equal. So from this we'll get two equations. So we know that S0 is equal to S0, 0 plus S0, 1. X1, X minus X0. Okay, let me remove just this one. Okay. X, okay, plus S0 to X minus X0. Squared plus S03, x minus x0 cubed. So if we take the first derivative of this ds0 with dx, we'll get, this is a constant, so 0. So we'll get this 0, 1, okay? Okay, plus 2 S02 x minus x0 plus 3 x S03 x minus x0 squared, okay? And the second derivative is equal to 2 S02 plus 6 S03 x minus x naught squared, okay? Sorry, it's not squared, just x, second derivative, right? This squared, so it is just x minus, okay? Now, if we go to same ds1 with dx, you will get the same equations, only here I get s1 0, okay, 0, sorry, it's 1 1. You apply the same for this s1 here, okay. For this s1, we apply it the same way, okay. You will get similar equation, s1 1 here, s1 1 plus 2 s1 2 x minus x1 plus 3 s1 3 x minus x1 squared. And for the second derivative, s1 x squared, okay, is equal to 2 s1 2 plus 6 s1 3 x minus x1. Okay, now we equate this equation, okay, so ds naught to dx evaluated at x1, okay, evaluated at x1, that's the intersection point, you will get what? Okay, you will get s0 1 plus 2s0 2 x1 minus x0, okay, plus 3 s0 3 x1 minus x0 squared, okay, and ds1 with respect to x evaluated also at x1, evaluated at x equal x1 here, at x equal x1 is equal to the second one, that's ds. So if we will evaluate that at x equal x1, all these will be zeros, right? So we'll get just s1, okay? So this is, okay, these are equal, okay? So we get one equation here, okay, from the first derivative. From the second derivative, ds 0 dx equal, again evaluated at x equal x1 is equal, okay, so it will be 2 s0 2 plus 6 s0 3 x1 minus x0, okay, and d second s1 to d x second derivative evaluated at x equal x1, you will get second derivative, okay, here here second derivative, here that's the second derivative, okay, you will get 2s1 2, okay, 2 s1 2 evaluated at x, so 6 s1 3 x1 minus x1 is 0, you'll get that, okay. So we get these, we equate these ones, these two, and we equate them, so we get another one. So this is one equation, okay, okay, this is equal to this, so we get another equation. So from the first derivative we get one equation, and second derivative we get another equation. So we have total 6 equations. We need another 2 equations, okay. So we have 2 equations from start, 2 equations from end, okay, 2 equations from first and second derivatives at intersection, okay, we left with the other two equations. We obtain them from the end points. Suppose that we have here one. So here is x naught, and here let's say xn, okay? So from the endpoints, i.e. from x naught, y naught, and xn, yn, okay? i.e. from SP lines S naught and S, I think it will n minus 1. The last one. This is first SP line segment, and this is last SP line segment. What we want actually is to define two values for the first segment and the last segment. And that depends on the type of the SP line we are looking for. For example, for a natural SP line, we want a second derivative with dx squared evaluated at x equal x naught, evaluated at the beginning is 0, okay? And for the last segment, n minus 1, second derivative with dx squared evaluated at the final value xn, here x naught, also equals 0. This will give you natural cubic, okay, SP lines. Okay, what that means, look at it carefully. If we have, let's say, here one point, here one point, here one point, here one point, okay? Here we have the first point. We have 4 points here. Here x3 in minus 1. Here x2, and here is x1, and here is x0. Okay? So we have 4 segments. What we want, the second derivative, okay, is 0. Okay? So we want sort of sublines. Here the first derivative of this, here is S0, here is S1, here is S2. So we have 4 points, means we have 3 segments, S0, S1. We have 4 points, means the last one is 4 minus 1 is 3, okay? So this is S0, and so on, okay? So x3, that's xn, 3 minus 1 is 2, so we have 3 segments, S0, S1, S2, because remember that we start at 0, not at 1. Okay. At this point here, we want the first derivative of S0 equal to the first derivative of S1, and the second derivative of S0 equal to the second derivative of S1. That's 2 equations. But for this also intersection between S1 and S2, we need also another 2 equations. So the first derivative of S1 equal to the first derivative of S2 evaluated at x2 here. And second derivatives of S1 and S2 are equal evaluated at x2. That's another two equations. So obtain, for this example here, how many points we have? 1, 2, 3, 4, right? And we have three SP lines. It's not 4 coefficients. S1 also 4 coefficients. S2 also 4 coefficients. So how many we have? 3. So we have 3 times 4 equal 12. We need 12 equations. From the start, okay, we have three equations. Start will give you 3 equations. End points will give you 3 equations. That's 6. Start means what? Start of S0 is this point here. Start of S1 is this point here. Start of S2 is this point here. Okay? End of S0 is this one. End of S2 is this one. End of S0 is this one. End of S1 is this one. End of S2 is this one. So 3 and 3. Now, from the first intersection between, okay, S0 and S1, between them you will get 2 equations. Okay? And between S1 and S2 you will get these 2 equations. Okay? That's for what? First plus second derivative. And here also first plus second derivatives. Okay? So here 6 and 4 is 10. We need another 2. And we take d is not squared, okay, with respect to dx squared evaluated at x naught equals 0. And the last one, ds2. The last one is 2. X squared evaluated at the final point at x3. Okay, that's the final point. We want the second derivatives of these segments of S0 at x0 is 0, and the second derivative of S2, the last segment, at x3 also 0. That will give you the natural, okay, natural. Okay? So we have 3 plus 3, 6, 2 plus 2, 4, that's 10, and here we have 2, that's 12 equations. We can solve them to obtain the parameters or functions, okay? So we can apply this in general, okay? In the notes, what you have, I gave you a sort of formula to obtain LMs and these things. Now I will give you the method that you can obtain without a formula, that you can obtain them directly by understanding these topics. So what we want to do, we'll organize the parameters as, okay, S, first the zeros is 0, 0, S 1, 0, S 2, 0, and so on, okay? So this will give you how many? It will give you the number of segments. We have, for example, in this example here, what we had here, we had 3 segments, S0, S1, S2, okay? It depends on the segment, okay? And then you start with, okay, S0, 1, S0, S1, 1, S2, 1, okay? And then S0, 2, S12, S22, and so on. And finally, S03, S13, S23, and so on. Okay? We define this as coefficients S. Okay? These are coefficients. Well, if you look at these are the constants. These are the linear. These are the quadratic. And these one are the cubic parameters. Thus, these parameters we're going to find. We have the number of segments, but times 4. This is the number of segments, for example, here 3, 1, 2, 3. We have only 3, but we have 4 parts. 1, 2, 3, 4. So 3 times 4 is 12, okay? Thus, we organize them in this way. Then we can define a matrix A times S equal B. And then S will be A inverse times B, okay? Now, how you find B? For the first equations here, we know that S naught equal Y naught. S1, S the Y1, S2 naught equal Y2, and so on. Okay, so we know the B's of the first, okay? So this will give you, and the A's also. For example, we can put it this way. Okay. Let me demonstrate that just for 2 segments, okay? For 2 segments, what I have is 0, okay, 0 and S1, 0, 2, okay? And then we have S01 and S11, that's 2, okay? And then we have S02 and S12, and then we have S03 and S13. So this is the S, okay? S for 2 segments, okay? Thus we have 8 parameters, okay? Now, if we look at these ones here, we say this is equal to, okay, the B's coefficients. This is B, okay? Now, the first 2 coefficients, this one and this one, belongs to this one. So we put here what? Y naught and Y1, okay? And here we'll be having 1, 0, 0, 1, okay? All the rest here are zeros. Okay, so we have identity matrix 2 by 2 for the first one. So this belongs to the start of the segments. Now this one for the end of the segments. Okay, so we can start also. This is for the first. For the end, we have Y1 and we have Y2. And we can insert here, we go to the end parameters here, okay. If we go back to the, what we had in here, these 2 equations. You remember Y naught and Y1 for the start, Y1 and Y2 for the end. Now we can insert these for the end parameters. We insert this one equal Y1 and this one equal. If you look at this one, we have what here? S00, okay? Evaluated at X1, so we have this one here, okay? So if we name X1 minus X naught as H naught, okay, then we have S01 multiplied by H naught. S02 multiplied by H naught squared. S03 multiplied by H naught. And S00 by itself. So if we put these ones into there, okay, what you obtain here, okay, what you obtain here is 0, 0, then you get 1 here, okay. I have nothing with S1, 0, is nothing you have with S0, 1 here, you have H naught, right? I come to this one here, back to it, okay, back to it. Now here, yes, so it's evaluated here, it's 0, 0 plus it's 0, 1, H naught is 0, 2, so that's for the first one. But for the second one, evaluated this one, okay, at x2, it should equal only, okay, here y2, y1, and here y2, okay, so then here is 0, 0 plus is 0, 1, okay, so we'll get what here, 1, and then 0, 1, which is here 0, here you have H naught, okay, and then 0, then here H naught squared, and 0, and H naught cubed, and 0, okay. Similarly for y2 here, you have 0, 1, okay, and you have 0 H naught, H1, and okay, and 0 H1 squared, and 0 H1 cube, and so on, okay. So these are for the starts and ends. Then we come to this another for first and second derivatives, and the final two for natural, okay. So if you put these ones, y naught, y1, 2, and they are okay, you'll get here actually 0, 0, 0, 0, because you equate the equations, okay. We don't have y's here, okay. Then we can obtain this matrix is A, this matrix is B, and this matrix is A, okay. Just following the equations, you organize the equations, you organize the first start equations, then the end equations, then you organize the derivatives, whether the first derivatives first and then second derivatives, or one after other, doesn't matter, and finally you organize the two equations for the second derivative of the natural equation and equate them to 0. That's why we have or 0, 0. Now I have made a program. I'll show it to you through the MATLABs, okay. This is actually, I want you to, okay, practice this program. I will upload it to you. But now for the moment, let's go to the MATLAB and see, okay, see how we did that, okay. Let me operate the MATLAB for you. Just give me a minute. Okay, let me just start the MATLAB. Okay. Okay, let's start. Okay. Now, in the MATLAB program, I arranged a file. I named it cubic spline. Okay. See, for example, here, xy, we define what is x, what is y. Let me just delete that. Insert. Let me put in here a remark and a remark here. This is similar to the example you have on cubic splines. Okay, so we had points. In our example, we had 4 points, 0, 1, 2, 3, and let me remove these 2 points also. And you have 0.5 to 1.5. This x and y. We determine the difference, that's h. You see here, you'll get an h. Okay, let me just run it and see how. Run cubic. Okay, cubic spline. Okay, cubic undefined function. Okay, I should go and to the path and set it as usual. Okay, add a folder, and the folder I put this in is 205, and select folder. Okay, it should operate now. Okay, now let's do it. Okay. If you look at it here, we had 4 points, x from 0 to 3, 0, 1, 2, 3, x. Okay, so we have 3 segments. The black one is not solid. Black one solid is S0. The red one is S1, and the blue one is S2. Okay, so we have 3 segments. This one is the first derivative, smooth, as I told you before, and this linear is second derivative. For natural, this is for a natural spline. You see the second derivative at this point here is 0, and at this point second derivative at this point is 0. That's from the 2 equations. We equate second derivative. Here we equate this is the start. Okay, start of S1, start of S2, and here is end of S0, end of S1, end of S2, and at x1 and x2 here, we equate the first derivative to the first derivative, and the first derivative here to the first derivative here. And also we equate second derivative with this second derivative, okay? They are the same. And here also they are the same, okay? So we obtain that. Now, to show you how, for example, we know this is x, okay? And this is y. To find x, we say the difference of x will give you a 3 by 3 matrix. It will give you a 3 elements. X, okay? X. It will give you 1, 1, 1. So difference will take this minus this, 2 minus 1, and 3 minus 2, okay? This is the definition of the difference. So we use h to find that difference. Now, n is the number of spline segments. So what is the length of x? We look at this here. What is the length of x? Length of x or y is the same, okay? Length of x, it's the same as the length of y, okay? Length of y is the same. okay? So, which means we have 4 points. So we have what? We have 3 segments, S0, S1, and S2. That's what it says here. So we define N in here as the length one. First, you know that how many segments we have? We have N segments. It means we'll be having what? 4 times N parameters. So the matrix A should be a 4N times 4N. So in our example here, we have N is 3, so it will be 12 by 12, okay? And we can, if you want to type it, just type what is A, but it's too huge, okay? Too large, okay? Okay. So this is A. You fit the first 3, because 3 segments is the identity matrix, and here also you have 1, and here -1, and -2 times, and so on, okay? If you want to find what is S, this is S, small, okay? This is S. We have 12, S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the same example, okay? You can put it this way, organize it as this way. So these are here S1 to N. So this is the constants 0.52, and linear parameters 0.1, 1.3, 0.7. And the quadratic 0, 1.2, -1.8, and the cubic 0.4, -1, and 0.6. If you go back to your notes and find that example, you'll find these coefficients there, okay? I want you also, if you go to these notes, I have the notes. I have few corrections for you. That's in page. If you go to page, okay, page 22. In your notes, at page 22, go to the. It says there M0 and M1, that's a typical mistake. Depend on the SP line, okay? And M0 and M1 equal 0 for the natural, okay? The natural. You'll find it there, okay? Correct this. This is not M1. This actually should be Mn, last one. And this one also corrected to Mn, okay? Correct, okay? Correct it in your notes. But we applied it in the example one, okay? So correct this M1 to Mn, last one, okay? And M1 to Mn, okay? So in page 22, you found that we calculated for M0 to N-1, because we know that M0 is 0 and Mn is 1. So that's the method, the first matrix, the method you learned, okay? If you check in that example, okay, you'll find the constants we have calculated using our method here is the same, okay? So I want you to practice this method, okay, for the cubic SP line. Okay, let me go and just find out this. Okay, you know how we construct A, and how we do A. We first make an A a 0, 12 by 12, or 4 times n times 4 n. That's just a reset A. And then we modify the first M 1 by, the first n by n matrix is I, identity matrix, so size n. In our case here, n is 3, so it will be 3 by 3 identity matrix. So this is the start nodes. The end nodes, study this, how we make this end nodes, okay? Here, as when I wrote h squared, h naught squared, h2 squared, h naught squared, h naught cube, okay? We start k. Here, naught, it means 1, okay? We start at 1 to n. N is the number of segments. And the number of segments in our example is 3. So 1, 2, 3. I did not start in 0 because I indexed it. So 1 means 0 in S. So H0, H1 here means H0. Okay? H2, H3 means H2, and so on. So just an index problem. So this is the start, and this is the end. And then I started the first derivative equations, and we go to the second derivative equations here. And then the endpoints, second derivatives equal 0. That's the natural. Okay, endpoints. Okay, this is, it means that we have a natural speed line. Okay, then B, y1 to n, that's y0, y1, and so on. And then y2 to n plus 1, y1, y2, and so on, y3, okay? And the rest are zeros. So this is B. Then we calculate S equal inverse A times B. And for each segment, XS, just I want to plot what is for segment, each segment 1 to n. The value from the first node, this is the first node of the segment, this is k plus 1, the second node of the segment, okay? And we made a step of 0.01 to make the curves fit smoothly. Then we calculated what is y segment for each segment. What is yd1, the first derivative? What is yd2, second derivative, okay? So yd1 first derivative, yd2 second derivative. And here just for the coloring, okay? Here if k equal 1, okay, the first or 5, we choose a black color, and we choose the first derivative is a dot, and another dot for the second derivative, and so on. Just a sort of giving different colors to each segment, okay? Then we plot each segment with a line width okay? So, here we have it, okay? Here again, you plot it and you see how it looks. Exactly the same plot as you have, okay? 3 segments. Now, let's go to the same program and just, this is the first. Let me just mark this as an explanation, okay? And an explanation, and use instead of this, okay? What we have here, we added to the first 4 points, we added another 3 points, 5, 6, 8. And here, the difference between first, second, third, and fourth is 1, but we jumped 3. 5 minus 3 is 2. 6 minus 5 is 1. 8 minus 6 is 2, okay? So we added different points. You can also practice adding more points, okay? Let's just do it again here, okay? Okay. Now, if you look at it here, how many points we have? Okay, 1, 2, 3, 4, 5, 6, 7 points. We had 4 and we added 3, 7 points. So we had 6 segments. The black, the red, the blue, that's 3. The green is 4. Okay, then black and red, another 2. So we have 6 segments. This here solid line is the S. This smooth curve is the first derivative. Okay, this linear okay, linear lines are the second derivatives. And you see the derivative here at this point here, okay, the end point is 0, and here also is 0. That's a natural speed lines, okay? So if we look at this, okay, let me see. If you want, for example, difference x, you see, this is the h, 1, 1, 1, 2, 1, 2, okay? So we have how many h? 6 h. For each segment, we have 1 h. And if you want to see the parameters organized in this way here, okay, that's the parameter. So here we have how many segments? 1, 2, 3, 4, 5, 6. 6 segments. So these are the constants of the segments. It's 0. Here is 0, 0. Here is 1, 0. It's 2, 0. It's 3, 0. It's 4, 0. And it's 5, 0. And here the linear is 0, 1. It's 0. It's 1, 1. It's 2, 1. It's 3, 1. It's 4, 1, it's 5, 1. And here the quadratic is 0, 2, it's 1, 2, it's 2, 2, it's 3, 2, 4, 2, 5, 2. And here the cubic, the last parameter, is 0, 3, it's 1, 3, it's 2, 3, it's 3, 3, it's 4, 3, and it's 5, 3. Yes, you can organize them in this way, okay? Practice doing this. You can add another point, doesn't matter. Let me add for you, for example, 8. Let me go to, let's say 12, okay? And let's go to y. Let's go to a negative. I didn't try that, -2, and see what happens, okay? And let's just run the program again. I didn't try that, just I'm trying it with you and see what happens. That's the one, okay? And see, it works. This is, we added another point, so we have 7 segments, 1, 2, 3, 4, 5, 6, 7 segments. And the last segments is from actually 8 to 12. Okay, and it's negative, you see, it goes to negative, -2 we have put it. But this is for the natural, the second derivative here is 0, and the second derivative here is 0, okay? So it works, okay? You can practice it, okay? I will end this cubic spline with you. I will upload this program for you through Watts and Blackboard, and both videos, okay, from the MATLAB and from the tablet, okay, both videos. The reason why I made this video for the cubic spline, because cubic spline is very often used in several sciences, in chemistry and mechanical and electrical. Not only that, in communications used. Not only that, it's used also in statistics and economics often. So it's very important to understand it, okay? Okay, and I will find out the other video. Don't bother too much about the marking scheme now. I will find out how we will manage it. What I want to is to practice now and understand the things. Inshallah, we will do lots of things. I will start maybe this week doing some quizzes and I will give you these quizzes, probably multiple choice questions to train yourself on it. Then I'll find with you a way, maybe in Ramadan, to during the night, for some way of assessment, maybe interviews or these things. I probably interview each one of you through the video. Okay, we'll find. Don't bother too much about this. We'll find a way. What's most important now is your practice. Understand the things. Solve the assignments. Be prepared that when I ask you to send things to me, okay, they are there. Okay, now work on the assignments, practice these things, and meanwhile, I will find out this week if I can send you some quizzes to practice to make you ready for the interviews. Okay. So good luck. I will talk to you in a few days. Okay. Thank you.